Emulation of attacks to validate Cisco security defenses. Atomic Test 1. We're going to leverage Secure Endpoint and Cisco's XDR. Now, there's a lot of things to happen to get to this point. So you may be thinking, why didn't you block it earlier? Well, that's not the point of the test. The point of the test is to determine two things: whether or not we have the capabilities to either prevent at some stage, but ultimately detect. So the first thing that we're going to do is run in audit mode, where we're not preventing the attack, but we're able to run the attack all the way through its life cycle and determine what in fact we detect. And then we'll move to prevention. So we're going to use the user account control bypass script and a modified version of Mimikatz. We're going to upload those to a directory and we're going to execute it. And the goal here is to bypass UAC and credential dump. Now, the tactic here is credential-access, and the technique is T1003.001. OS credential dumping, LSASS memory. And you can check that out. You can just go to the MITRE ATT&CK framework or pivot from any of the tools. The other one that we're going to test as well is suspicious process path fonts. So basically, there's an executable in a directory that really shouldn't be there in that directory because executables are not found there. And it's executing and making a network-based connection outbound. All right, so what does the environment look like? Well, we've got a Linux box that's running Caldera. Now, Caldera is going to allow us to run the breach attack simulation that we're trying to achieve here. And on an endpoint, we have the Cisco Secure Endpoint, we have the Network Visibility Module, and we have Caldera, all bundled up into this endpoint, which is going to allow the agent Caldera to make the requests, and hopefully we have the ability to detect credential access and defense evasion. Let's get started. All right, we're in Cisco XDR. What I want to show you here is here's the client that we have the Network Visibility Module installed on, including the Cisco Secure Endpoint. And this is just showcasing that it's managed by Cisco XDR, and we can add additional modules and configurations. We have no incidents at this point in time. All right, let's go ahead and pivot into Cisco Secure Endpoint. We'll go to Computers, and we'll drop down the audit policy. And we can see here, the audit policy is assigned to the asset that we're testing with. And audit is just going to allow everything to run, but audit everything that's happening. And hopefully we can catch everything that takes place. Now, I'm just showing you the endpoint now, just to make sure there's no smoke and mirrors here. We are in audit policy and we are not isolated currently. All right. Let's jump over to XDR, the network detection response. We can see there's no alarms here either. Now we're in Caldera. Here's our agent. It's elevated privileged. It's installed on that asset, as I mentioned. We're going to create an operation here. We'll give it a name. We're not going to use any adversarial templates. There's a fact source. We can go to advanced. There's lots of stuff around grouping that we can do here. We can do obfuscators. We can do run at start or pause on start. I'm going to pause on start, and I'm going to add the tests here. Now, let's go ahead and we're going to use PowerShell, and I'm going to do a search for UAC, and we're going to scroll down to find that T1003.001, and as we scroll down, oh, there's one there. This is the one I'm looking for, UAC bypass and credential dumpings. Now, the nice thing is I can see the script that's actually being used here. We'll go ahead and add this link, and we'll close this out, or we can go back. In fact, we'll do that here. And I'm going to look for NVM. Now, these are ones that I've built or created to help detect some of the things that are happening within the Cisco security stack that may not be detected using other tools. So this is going to allow us to look for that process in that font directory that's being executed, that's making that network outbound connection. Now, not everything with EDR is going to be successful, and not every asset can be installed with an agent. So network visibility is key in obviously seeing what happens. Now, we ran the test. We can see the output here. Everything was successful. And we can see that there was a success even making the outbound connection, running that executable from the fonts directory. So we'll go ahead and stop this. Let's go to events real quick and refresh this. Did we catch it? And look at that. We've got a bunch of alerts here. We look at where we were updated last is right here. The very first one, we can see we've got a bunch of tactics and techniques, much more than what we were testing against, because it actually picked up the ingress tool transfer, user execution malicious image, system services for techniques. We can also see here that we got that FOD helper, and it gives us an explanation of what that is. And again, the tactics and techniques that were executed against that particular executable here. And we can see that we can drop down here and take action against a file at any point in time. And as we go up, we've got a low event. And here's that T1003.001, credential dumping LSASS memory. Fantastic. We, in fact, caught that here on the endpoint. Now, as I mentioned, the endpoint may catch everything. Oh, there's that file that's mimicking Mimikatz. And we can see an executed malware IOC that was triggered as well. But here's where NVM came in, or the network visibility, the ability to scour the network and look for things that might be happening, both on the endpoint or using just network telemetry from switches and routers, firewalls. And we can see here that we also caught that process execution from the font directory. We can see curl was used as the process. The parent process was PowerShell. We can see the arguments that were passed, all the details here as well. Fantastic. Now let's go over to XDR and look at that. We can see 2 incidents that were created here. So if we go ahead and look at the first one, this is progressive disclosure. We're showing you the right amount of information at the right time. Let's go ahead and pivot into incident details. And here we can see the relationships between the process, the user, the details that are associated with it. We go to the detections and we've got all the detection flags. We can see that UAC bypass through FOD helper. We can see the executed malware IOC and a bunch of medium and low events. Now we'll go back to incidents. We'll go ahead and look at that suspicious process path as well. And we can see that's 1000. We can see defense evasion was triggered here as well. We go ahead and view this. And again, we can expand this out. We can move this around as needed. We can pivot in to see, is it 1 user or 2 user? We can see there's 2 users associated here. And then we've got the endpoint. We've got the outbound connections, the URL that it was connected to, the file path, and the hash that was executed. So we got all the details that were required here. And this was flagged as 1000, which is the highest severity. We go ahead and look at the detections. We can see that this was caught by Cisco XDR analytics. That's that network detection and response capability that I was talking about earlier. All right, let's go ahead and hit incidents. Let's go ahead and delete these incidents. And let's go over to Cisco Secure Endpoint. We'll go to computers. We're going to go ahead and change policy here. Now let's go ahead and put it into protect mode. Now this is only going to prevent the attack as early as possible. That's the goal here. But remember, it's only as good as the EDR and the EDR's capability. Cisco Secure Endpoint will allow us also, maybe based on the event severity, is maybe isolated automatically. I'm not going to do that here. The tool can do it all by itself. What I want to show you is that we can actually drive that outcome from Cisco XDR. All right, let's go ahead and double check that the policy is in fact taken place here. And it says not isolated and it's the right policy. We'll go ahead and let's go ahead and rerun the operations. We'll start from scratch here. We'll grab that UAC bypass. It's PowerShell as the executor. Let's scroll down. And there it is, UAC bypass credential dumping. And then we'll go ahead and we'll add that NVM test around the process executing from the font directory. And remember, this is one I just added myself. I created my own abilities within Caldera, which is pretty cool. They're added and they're running. And we'll give it a few seconds here for the results. So we got error code here. Although it says success, there's some errors here. All right, let's go ahead. And we can see from our last update right here, we've only got 3 events. So we see that threat was detected and quarantine successful. UAC bypass through FOD helper. So we could see that, in fact, we were able to mitigate the risk here. Now let's go ahead and look to see if we have anything showing up here in the XDR network detection response capability here. And we did. We actually flagged that here and caught that process that was executed on an endpoint from a directory that shouldn't have executables. And here's what's really cool. This is the attack chain that's being built, and it's seeing things that I've done in the past: discovery, credential access, defense evasion, command and control, and it's flagging that there might be some relationships correlated with each observable that was detected. Now, if I look at that attack chain that was built, I can come in here and I can see initial access, persistence. There's a lot of things that were triggered here. I can expand that out like I did before, very similar. I can drag and drop and move these around. I see the relationships between the IPs, the URLs, the users. But the bottom line is that not only did I prevent the UAC bypass from taking place, but I also was able to detect, not prevent in this case, but detect, which is key, the asset having an executable in a directory that doesn't normally see an executable and executed from it. Now, what I'm doing here is we're able to do response actions, either automated or manual, and I just kicked that off. I just isolated that endpoint using Cisco XDR. And look, I can't ping. The only exclusion would be whatever exclusion that you give it, that it could still maybe access certain things. Obviously, we can still manage the asset because we don't want to lock ourselves out of that. And let's go ahead and look at our inbox here. We can see that the asset is isolated, in fact. And we can see any of the related compromised events. And we can go ahead and maybe we've remediated this through a ticket, and now we've stopped isolation and we're bringing that asset back online. Now, how long does it take? It's actually pretty quick. You can see by the time I got back to the endpoint, it was already showing up as not isolated. Now, this varies a little bit, but it doesn't take a whole lot of time. And now that asset's back up and running. Now, obviously, we want to remediate what took place here. Now, we can also go into debrief. We can get a little bit of an idea of the tests that we've done and the results that were found using Caldera. So we'll go ahead and select the right test here. We can see a C2 server, which is our Caldera box. We can see the endpoint. We see the agents. We can see the username, the privilege level, and the steps that were taken here. We can show commands. And then here we see the tactics and techniques that were being tested against. We were able to detect the executable being executed from a directory that doesn't normally see executables. And we were able to prevent the dumping of credentials. All right, atomic test 1. Let's look at the results. So we were able to detect and prevent credential access using T1003.001 OS credential dumping using LSASS memory. The other thing that we were able to detect, although not prevent, but detection is key, was defense evasion using Masquerading by executing that process from a directory that doesn't normally execute processes from. Now, full results are detection engines. We had things like threat detected, system process protection, exploit detected, cloud IOCs. These were things that were triggered. Prevention capabilities, quarantine successful, isolation. Tactics, we saw all kinds. We've seen execution, command and control, resource development, persistence, privilege escalation, defense evasion, credential access, lateral movement, and credential access again. And the thing here is we not only caught the 2 items that we were testing for, but we were able to detect a variety of other elements just based on the tooling itself and the behavior of the test. So testing is key, and the results will vary, but ultimately you have to detect and ideally prevent the core elements that you're testing against. Now, here's an example that I wanted to show you a little bit more detail around Cisco XDR. And now you can see users, and you can drill into user names, the file paths, the executables, and you can see up here, we see the relationships between the processes themselves, and we can flag whether or not they've been deemed as malicious or suspicious. We see the endpoint, but this could also include things like emails, the subject, the recipient, all the details around that. So not only do we see it coming in through all kinds of different sources, but we see what happens once it's executed, and that as it travels the network, there's no way of hiding here. So summary, detected and prevented the credential theft, leveraging Secure Endpoint. We detected the process impersonation using Network Visibility Module. We built an attack chain leveraging XDR. Now we didn't. Cisco XDR looks at those observations from all those different sources and decides whether or not they are related. And we isolated the host for process impersonation using Cisco's XDR. We did that through a manual process. This could be automated through Cisco XDR, or it could even have been automated through Cisco Secure Endpoint. Pretty cool.